Okay, I think there's a lot of people already waiting, so I think it's a good moment to start. So hello, everyone. Thank you for joining us for this webinar, where we would like to introduce a new feature of our cybersecurity solution. This webinar will be hosted by our CEO, Ivan Klimek. I'd like to say that this session will be recorded, and in case you would like to turn off your camera, please do so now. If you have any questions, we will share an email address at the end of this session, and you could send us the question. We will answer afterwards. We will try to answer every question, and we will contact you after. Now I'd like to pass the word to our CEO, Ivan Klimek. Ivan, it's yours.
Thank you, Susanna. Hello, everybody. Hello, ladies and gentlemen. I hope you can hear me good. So, first of all, thank you for finding time and being here today with us. We really appreciate it. What we are going to show today, everything you will be able to play around yourself very soon. So think of it like what I'm trying to do with this webinar, what we are trying to do with this webinar today is just to give you an idea what is incoming in your next release that will be released by the end of the month, so that all of our partners, if they are interested, can already try to start playing around and testing this newest feature of our product. So maybe to introduce the whole topic, I will start with a basic introduction into how it fits into the overall Excalibur product and what the product does. Maybe not all of you know all of the kind of like logic behind, so this can act as a quick introduction, but also to get us started, and then it will make much more sense as we proceed, and I will show live demos and we will go a little bit technical into how it actually works and what you can try around with it soon when you have it deployed for your internal use cases. So just a quick reminder, the classic architecture, what we are always talking about, we call it Excalibur SAM. SAM stands for Streamed Access Management. What we mean by that, it is a little bit of wordplay for privileged access management, because when you think about privileged access management, the word privileged kind of like limits the scope, limits only to the privileged users, and we want to kind of like show that you can use the same best practices not only for the privileged users but for any users, and then it becomes streamed access management, because how we provide access to those resources is by streaming them. So what we are doing is kind of like shown on this picture, where you have your resources here in the middle. This can be some kind of servers in some network segment, or there can be individual machines, and instead of exposing them directly where they could be attacked, you hide them behind our solution, which can connect directly or via tunnel, which is a new feature in our V4 release, which if you did not yet try, I would highly encourage you to try. It allows you to basically tunnel to any kind of network segment without direct connectivity from our servers, which means that these servers can run in any kind of private, public cloud or on-premise, whatever you want, but they don't have to have direct connectivity to the resources that they will be streaming access to. So you just create tunnels. These tunnels are then used to basically reach these resources from our server. Our server then basically terminates the protocol and streams directly to the user browser, and the user can use their mobile phone or passkeys to passwordlessly authenticate to the browser and basically use all of those resources that are being streamed to him. So everything's streamed to the browser, so that's why it's called Streamed Access Management. And this basically is what we are doing for some time now. Let me show you live, just a quick reminder. So here I'm in our dashboard. This is our V4 dashboard. I'm logged in as basically administrator, and we see some PAM resources here. So classic SSH, let me just launch it. It launches on a new tab. It shows you are being monitored, everything is being recorded. Now I basically can do any kind of activity here, and it's being streamed directly to my browser. So I have no direct access to the target system. I only interact with the stream representation of its output. Of course, it doesn't need to be only SSH. It can be anything else. Like here we have an RDP server. So I clicked on it, opens on a new tab. Again, every time you see a warning here that you are being monitored because this is recorded. And in the next release, this will also add some AI features to real-time anomaly detection, but we can talk about that later. So as you can see, classic functionality, you saw this probably many times, everything is being streamed. But as we have been developing this, more and more requests from our customers and partners were about web resources. And what we normally did for web resources until now was that we used remote apps. So let me demonstrate what I mean by that. So if there were some web resources that needed protecting, what we did is that we used an RDP server, which basically ran an instance of a browser, and this browser was packaged as a remote app. So remote app is a name for this technology from Microsoft, where you can basically create a application that when you connect via RDP to that server, it will launch only that single application with a parameter, whatever you specify. So this is what I'm showing here on a text-heavy web page. And as you can see, the problem with this is that the user experience is visibly degraded by latency. I'm not sure if it's so visible on via sharing via video, as I'm encoding to video from the Teams meeting, but basically the readability is reduced, the latency is there because everything needs to be encoded to pictures and streamed as pictures, which degrades the quality and user experience. So we were thinking for some time now, how could we possibly do this better? How could we possibly stream access to web resources so that user experience is not degraded, but we still have some isolation properties? And that was basically how we got to the technology which I am going to present today, which we call VITRO. VITRO is from the Latin in vitro, meaning behind glass, in glass, like vitrification, if something becomes like glass form. So VITRO, as the name suggests, what it tries to do is to create a situation where the web page would be like behind a plane of glass. So you cannot touch it, but you can see it, right? So that's what the name stands for. And it is basically our remote browser isolation technology. So what I mean by that, remote browser technology, you probably heard about. That's basically where you are running browsers somewhere in cloud on a server, and you are streaming their output to the user. But usually how RBI is done is that you stream to video, and that is, of course, expensive because encoding full HD in real time, how many parallel sessions can you do? Even on a GPU, or you can do only a very limited number of such high resolution real time sessions, and thus this makes it cost prohibitive. So we were thinking, how could we possibly do this better? And even if we would be streaming via video, it would not only be expensive, it would also still have latency because the encoding process takes time, the network takes time. So ideal situation would be to create a system where there would be zero latency. And what I mean by zero latency, let me show you. So the only way how zero latency can be achieved is by creating what I call local interactivity. So let me now switch to a target. Here, these are VITRO targets with these web icons. So I will go to the exactly same page like we did here. So this is via remote app, streaming via pictures. And now let me open the same via VITRO. So I click open on a new tab. Let me zoom in a little bit so that you see something. And basically, this is now VITRO rendered. There is no latency on scroll. There is no latency on textual inputs. There is no degradation of visual quality because all of this is locally interactive. Let me now spend a few minutes on explaining what I mean by locally interactive. So this will be a little bit technical, but please bear with me. I will explain everything what we are doing. So let me open developer tools and let's look under the hood of what we are actually looking at here. So if I go to the network and I refresh it, we will see that all of the resources that are being loaded here are loaded from only one domain, one server. And this is this server here, which is our VITRO demo server. and all of the resources, all of the pictures, everything is loaded only from this one server. So, and what is happening here? So let's analyze it a little bit. So here we see a WebSocket. So if I click on this WebSocket, I will see all of the messages that are being sent up and down from this client to the server. And as we can see, if I'm scrolling, something clearly is being sent to the server. And if I click on something, I receive it somewhere. So let me find it, what we receive based on size. So we see this size here is large. So let me just click that. And we see there is some kind of snapshot being sent. So what is this snapshot? So if we look at it, basically this snapshot is JSON formatted HTML. So what is happening here is that on the server side, the page is rendered, and we take the static document object model once it's fully rendered in its static final form. So it's pure static HTML. There is no JavaScript. Let me copy it to some editor so that you can maybe better see it. So editor. Okay, let's go for this one. Here. And sorry, it's not very nicely formatted, but this format document takes a moment because it's large, or I have a pre-formatted here. So basically, if we would analyze it, we would see that what is being sent are just basically mutations of all of the document object model objects on the web page. So whatever on the web page changed, it is basically streamed to the client in the static HTML format, and all of the links are rewritten to our server. So that's why when I showed the network tab, you saw all of the links and all of the resources being loaded only from us. So what this means is that what you are interacting here with, this is static HTML rendered output. So on static HTML is locally interactive. So that's how we can hide all of the server and network latency, because it is still there. Of course, it is still there, but you do not perceive it because the page that you are interacting with, you can scroll, you can type, you can do whatever with it, and all of the latency is basically asynchronously hidden from you. So you don't perceive it, it doesn't block you. And because it is static HTML, there is no visual degradation that you would normally get if you would be encoding to pictures or video or any other format. So I can do however fast scrolling I want, or text copy or whatever else. You will never see any visual fragments as you would see here on this remote app variant, where I can scroll and get all fuzzy and, you know. So if you would be working with a version of RBI that is encoding to pictures or video, and you would be doing text heavy stuff, which most web tasks are, then you would probably, you know, get some migraine or something like that from the visual degradation. Will not happen. So basically with VITRO, you have no degradation of visual quality, you have no latency, but there is still only half of the story. So now when we established what we are looking at here, let me just very briefly switch to slides and recapitulate what I was just showing it here in one slide. So basically, the novelty is that you cannot modify the web page in any way because you are only interacting with the visual representation of its output. So all of the details of the internal workings of the web page are not accessible to you because they are happening on this remote browser isolation instance of the browser on a server. So you do not see what requests it is doing. You do not see what JavaScript is executes. You do not see the cookies. You see basically no details of the inner workings, and you cannot modify them. So you cannot attack the web page. The user is also protected because the only thing that comes to the user is the static HTML, and static HTML basically has no way of infecting you with any kind of exploits, because if you look at any kind of statistics of exploits, all of the exploits are always JavaScript based. So if JavaScript never really gets to the client, then basically there is nothing that can exploit the client. So it still performs the core function of RBI, and that is protecting the client, even though we can now also use it to protect the web resource, which nobody ever before did. And I will come to that a little bit later. So, and as I try to explain, it's latency insensitive, and this is important for not only the user experience but also for cost effectivity. So, one of the ideas that we have in mind is that because latency uh, is hidden from the user, we can run the instances of the server not where it is the closest to the user as normally you would normally do. Like in a classic RBI situation, because you are always bound by latency, you would try to have the instances as close to the user as possible. And this is problematic because when you look at basically how the demand for compute uh, in any kind of cloud scenario looks like, it's basically a function of time of the day. Like when you are like 2 p.m. afternoon, there is maximum peak traffic. So any kind of on-demand cloud resources are most expensive. But when we can run it where it is cheapest, not where it is closest, then basically we can run it outside of the peak time. So we can run it like behind or after in time zones different than yours, because it doesn't need to be geographically closest. And this enables spot VM usage, which is basically like 90% cheaper than normal VMs in any kind of cloud scenario. So this is a direct economic effect of this latency insensitive design, which no other solution has. So, but what I'm most interested to talk about today is the security properties. And I think this is also why you all joined here today, because this is the true disruption. So normally, how everybody else right now operates is on basically trying to filter what is malicious from what is not malicious, right? So if you look at any kind of web application firewall or even antivirus, doesn't really matter. It always has some kind of rule sets, and these rule sets have to be updated. And if they are not updated, then you are not protected. But this also means that static rule sets can never really catch zero-day attacks. And zero-day attacks basically just means a zero-day attack is an attack that nobody saw before. And by definition, if nobody saw it before, there cannot be any kind of rules to stop it, right? So that's why all of these rule-based approaches are ineffective against zero-day attacks. But now we change the game, and we no longer even try to filter, right? So we are not filtering at all. We are isolated, right? So that's why this visual representation with this glass bottle was in vitro, and we terminate and stream. And basically, there are no rule sets at all, right? Because we are not trying to figure out what is a good network request from what is a bad network request. We don't care. We just stream the output, and you have no way to interact with. Of course, these are very, very strong claims. So that's why we have this webinar, so that I can show you live, and you will also be able to play with this yourself. So let me just show some quick demos here, what I mean by that. So what we usually use for these demo purposes in an application is called DVVA. Let me show it. So DVVA, this is an application you can find on GitHub. It's basically, as the name suggests, damn vulnerable web application. So it has, like massive amounts of exploitable vulnerabilities. And right now I need to do a little bit of window management. So let me put this here. And here on this right side, this is a DVVA instance that is unprotected. That is basically, I'm directly accessing it. And this is a DVVA instance on the left side on our VITRO demo server. So basically, this DVVA instance is protected by VITRO, and this on the right side is not. So let me just go and do some quick hacking here. Let me log in. So let's reset the databases so that we are sure we have a clean environment. So reset. Now let's go and check that the security is low. Security level low. So now we have the same on both sides. Let me go and do some SQL injection. So I will just do a simple one here. This is the correct input, so it should go through. So on both sides the same. But let me do an SQL injection. So I will do a classic classic 1 is equal to 1, is a logic statement that is always true. So if this is unhandled, it will just return everything in the database. And as we can see, it dumped me everything that is in the database because the statement was always true. So if it's not handled in code, then basically if the programmer did not implement some security protection mechanisms, it will just go to the database. And this is just a very simple example of an SQL injection. But if I try the same on VITRO protected instance, absolutely nothing will happen because it detects and blocks this input. So this is the final piece of the puzzle. Not only that you can not interact with the internals of the web page because it's just being streamed to you as a visual output, but the only thing left that we need to worry about are the inputs from the user. So that's why I'm demonstrating this here, because this is the input from the user that goes to the protected resource. And because VITRO is streaming it, it can look at the input and see if it's okay or not okay. In the first release, pre-release version that we will bring out later this month, basically this will be handled very simplistically. But we have a lot of AI, very cool AI stuff in progress that we will release later this year, where you can think of it that if there would be any kind of anomalous behavior detected, there will be a feedback loop mechanisms that it will tell the user that what he is trying to enter right now, it's an anomaly, and he should try to rephrase it if he thinks it's a valid input. And it will iterate with the user until it is considered safe. So a lot of AI work worked on right now, which we will release later this year, and on top of this base VITRO construct. So let me show some more examples. So for example, this is also fun. This is a stored XSS. So basically how this attack works is that now there is some kind of guest book, and I would just write something here, like let's say Excalibur was here, test, whatever. And basically it will just give me write it here, right? So we have a new guestbook entry, and basically let me copy paste something there. I will do the test. And now what I'm trying to do here is that I'm adding a script that will just throw a prompt when it goes in. And this is the prompt. And now what happens is that this is called stored because it's stored here in the guestbook. And whenever I go and click back, I will always get this prompt again and again. But in VITRO, absolutely nothing will happen, which is the correct behavior, and it was not even stored, so it doesn't even go through. So very simple demonstration of the input handling in terms of VITRO, but the core properties of VITRO is that even without this input handling, most of the attacks are fundamentally impossible because you just interact with the streamed output of the RBI instance. And until now, nobody ever tried this because it was economically unscalable, right? It was infeasible from the economic perspective for multiple reasons. So the first reason was that everybody, if you look at Citrix RBI or any other cutting edge RBI, why are they so expensive? Because they usually encode to video, and encoding to video it's GPUs. GPUs are limited. You need real time. You need at least full HD. So do the math. But there are other problems. For example, usually how RBI are constructed is that they create a virtual machine for each user session. So each user session has their own virtual machine, and in that virtual machine they have their own browser, and output of that is streamed to the user. So if you look at Chrome and how much memory it needs, basically that's at least 2 GB of RAM for a single user. So how could you possibly, scale that to thousands of parallel users? It would be cost prohibitive. So one of the things we did was that we rotated the concept slightly, and what we are doing is tab level isolation. So think of it like this: if you have a Chrome instance and you have web pages on individual tabs, then go to task manager and look at how much memory that takes, and then try to do the same but each of the tab on a new window. And basically there's like an order of magnitude difference in memory usage. But why is this even possible? This is possible because we realize that if we are operating in a web application firewall context, then basically the web page that we are protecting, we don't have to consider a threat, right? So basically the security assumptions in a web application firewall is that the web page is trusted. So we can basically reduce the security requirements for the session isolation and do step per each step a session. And this also then allows for effective memory deduplication and all of these nice things that kind of like just reduce orders of magnitude for the usage of memory. So this is a hack because RBI is compute and memory restrictive. And now with both these methods, streaming the document object model mutations and tab level isolation, we basically solve these scalability constraints. And now that allows us to basically, for the first time ever, use RBI to construct a web application firewall. So what we are showing today and what we will give all of our partners in the next release is a pre-release, right? So even if you are adding a target like I'm trying here, you see that this is a preview and it will be hidden behind a flag. And for first, we will only add it in here in PAM target so that you will be able to use it to protect your internal web applications and try around to play with it. And we will try to work with all of our partners that will want to work with us to iterate on the design until it fulfills all of the requirements. And maybe then later down the line, we can stand alone it so that it will not be only as a target in our PAM, but it will be like an actual web application firewall. So I know when I'm talking about this web application firewall stuff, it might be slightly confusing what I mean and how this is a part of a PAM. But for now, in the very first release, pre-release, the web targets that are rendered through VITRO will be only available as PAM targets so that we can have like some way of giving this to partners so that they can play around with it, experiment, iterate with us, and later down the line, while once we achieve like a good enough performance on all of these parameters that are required, then we can stand alone it and have it like a web application firewall. But for the foreseeable future in the next months, it will be just as a target selection option here for privileged access management, and we will decide how we proceed, based on the feedback we get and what we can achieve here. So let me jump back here. All right. Okay, so this is like a last slide I have here from the technical perspective. It is just a recapitulation of what I was showing in the output of the browser where we were looking at the messages flying around. So this is just a schematic representation of what you saw. So basically, this is the remote browser. This is the server-side component which renders the web page. And as it renders the web page, there is a component called mutation observer. This is a JavaScript function that is injected into the browser via extension that basically handles all of the life cycle of the browser. And now what it does is that if there is any kind of mutation, meaning a change on the web page, it will try to cache any kind of resources and stream it using a WebSocket to the client. And the client is basically what you are looking at in your browser, where the static document object model is being injected with the recent mutations and continuously updated in an asynchronous manner. And anything you are clicking there or typing, it just goes back to the server and gets injected there. Again, fully asynchronous, non-blocking anywhere, right? So this is the construction, and this allows us to basically keep all of the dangerous stuff like JavaScripts or dynamic CSS and all of this fancy stuff isolated on the server because it could be a possible threat. But on the other direction, because the user only interacts with this visual output, he sees no details of the actual execution of the web page. He cannot affect them, and all of the inputs can be effectively monitored and contextually reasoned on. So all of this contextual reasoning on top of user behavior is basically the AI magic that we are working on that we will release later on. during this year. But the first pre-release that we are unveiling today and will be available to you later this month will not yet have the AI features that are heavily worked on. So we will just ship the basic VITRO construct so that you can start with your internal apps. We will be very grateful for any and all feedback. Please do not expect this to be perfect on the very first pre-release, but the core technology is sound. We have been working on this for many years now. It has been uh, basically independently verified by Citadel pen testers. Uh, so it should do what it needs to do, but it will have, of course, some effects further on. And as we go and iterate on it, it will become better and better. So, of course, it's not limited to only such simple pages as DSL. I have some other targets here, like for example, let's try BBC. And as you can see, any kind of dynamic web page, even heavy as this, will work no problem without any latency, without any visual degradation. And features like video and this kind of real-time content will be shipped later on also, because for now video is kind of like out of focus because in internal web applications that are our primary focus area for now. We don't expect people to have like Teams calls through VITRO, right? That's not like the target case for this. The target would be any kind of web applications that you have that are internal. And usually, what we discovered when we talk with our partners and with our customers, we see that most of the technical depth is usually hidden in those internal web apps that you just have there sitting there forever because they do some kind of business function, and as long as they perform the business function, you are not investing any more money into them, right? And that's usually where the technical debt keeps accumulating, and that's basically how you get hacked later on. So if we can somehow make all of these web applications isolated so that you cannot attack them, we reduce the attack surface by a great deal. And as the product gets better and better on these web pages, it will become capable of protecting whatever web apps, even for external e-government or whatever else you might have that is like high critical and needs to perform and cannot be exploited by some web exploits. So lots of stuff that is new in V4. We had a webinar on this, and we will have many more webinars describing all of the new features and how it all fits together. But for today, this is it. I just wanted to kind of like give you an introduction, what to expect. If you are interested to be an early adopter, early tester, basically work with us to make this better, please reach out to us. We need you. We need your basically feedback. Else this will not become better. We are, working on it for years and trying to make it as good as we can, and whatever web targets we can figure out, think of. But usually, partners and customers have this talent of surprising us with something we did not expect. So how do you figure out what you do not know? You need to talk with people. So that's what we are trying to do with this webinar. So thank you all for being here. We are not going to have a question and answer session at this time, but Zuzka will ask you in a minute or two. Please reach out to us. We want to talk with you. We want to know what use cases you can think of when you hear of this technology, and what would you like to do with this, and maybe you will have some ideas that we did not think of, and we can do some great together. So thank you all, and that's all from my side. Zuzka.
Thank you all for joining us and for being here. You can reach out to us on our mail, Excalibur or XCLBR. It's kind of hard to spell, but it's on our website, getexcalibur.com. Unfortunately, I can't put it in the chat since it's turned off. But on our website, getexcalibur.com, you will find every contact where you can reach us and send us your questions, and we will for sure answer every one of them. Or thank you,
Yes.
Ivan, for sharing it. That's all from our side. Thank you everyone for being here and see you next time. We hope to organize these sessions more often and these webinars.
Thank you all.
Thank
Bye
you.
bye.